My name is Alex Kolodkin, and I'm a professor in the Department of Neuroscience at the Johns Hopkins School of Medicine. I was very fortunate to be honored with the Prattle Research Award of the National Academy of Sciences in 2016, focusing on our studies over the years to understand the molecular mechanisms that orchestrate the elaboration of neural connectivity during development. This award came at a time when my laboratory was in the process of transitioning many of our efforts towards understanding how neural connections are established and maintained in the mouse visual system. I thought at the time that these funds would best be applied to funding junior investigators in my group who are part of this research direction. As an example, we have had for quite some time focused our efforts on identifying axon and dendrite guidance cues, the receptors that mediate their effects, and neural systems that use these signaling events to direct neural connectivity. At the time of this award, we began to think about ways to understand in more depth the signaling events that encode select neural tuning properties. As a result of our past work, we had learned quite a bit about how a particular circuit in the mouse visual system devoted to image stabilization is wired during neural development. And this led Tim Al-Kindi, a talented MD PhD student in my group, to employ creative transcriptomic profiling approaches to investigate differences between very closely related retinal ganglion cells that differ only in their sensitivity to upward or downward motion. The question being, what is the molecular basis of select direction-selective visual system responses? This approach has worked out very nicely and drives much of our work these days. We have found transcription factors, cell surface molecules, and morphogens, just to name a few, that are selectively expressed in retinal ganglion cells tuned to only upward or downward motion. Importantly, mutations in several of these genes lead to select disruption of image stabilization in the vertical axis. And this is where use of the resources generously provided by the Prattle Award have come into play. It has been particularly satisfying over the years to include undergraduates in our research efforts, and we've always had at least two at any one time working with us. Not long after recognition with this Prattle Award, I was approached by Michael Sherman, a talented Hopkins undergraduate, about research opportunities in our group, and this led to Michael working with us during his senior year and then staying on as a research associate for 2 additional years. Though Michael had very limited laboratory experience in neuroscience, he quickly became a valued member of our group and contributed substantially to our efforts to understand direction-selective circuits. Indeed, he was clearly bitten by the research bug and independently investigated a range of new approaches for studying our mutant phenotypes, including computational approaches for understanding the intersection between retinal ganglion cell dendritic morphology and directional tuning properties. And in the midst of the COVID pandemic constraints, Michael even took on the training of a Hopkins graduate rotation student, a student who actually chose to join our group in large part owing to working with Michael. I was so pleased to be able to apply Prattle resources to fund Michael's stay with us, and I am very happy to note that he is in his first year of PhD training in neurobiology at Harvard Medical School. He is clearly destined to be a future leader in the field. It was a pleasure to watch Michael develop into an independent neuroscientist. Being able to host him in our group is a lasting benefit of being honored with this Prattle Research Award, and it highlights for me the importance of providing a supportive and vibrant training environment that works for trainees at all levels.